Alrighty, welcome back, ladies and gentlemen. We're looking now at section 2.2, day 2, higher degree polynomials. Okay, we're going to be graphing polynomials by hand, approximating zeros, and solving word problems involving high degree polynomials. Okay, I've got a set of directions here for graphing these things by hand, and I know you're excited to do that. We're going to apply the lead coefficient test, find and plot any real zeros, plot points between the zeros, the book refers to those as solution points, and then draw a smooth curve between the points. Alright, now this is basically the problem set that has you do this. These steps are all laid out as parts A, B, C, D, etc. So I'm just kind of mimicking what the book's going to do for you. So here we go. Alright, so we've got our f of x equals negative 2x to the fourth plus 8x squared. Okay, applying the lead coefficient test, to me, mostly just means getting a mental picture of what this guy's going to look like in our heads before we get too far into it. Okay, now as soon as I have this x to the fourth, and again the lead coefficient, maybe I should say that first. Lead coefficient again is the coefficient on the highest power that you have. Okay, and the book will sometimes change the order of these things, so be careful, look for that highest power on all the terms before you make your decision. But anyway, here we go. Okay, x to the fourth, even power, I know both ends are either up or both ends are down. Okay, then looking at the negative lets me know that, hey, well, the choice between up and down is down this time. So I know this is going to go both ends down, and just as a rough idea, since I have a fourth power, I know I might have as many as 3 turning points. So I know this guy's going to be down on one side. I might go up, down, up, so again 3 turning points and going back down. So it might look vaguely like that. Again, I'm not concentrating on being overly accurate right now, but again, our basic graph should look something like that by the time we're done with it. Alright, and now continue with our example. We've got to find and plot any real zeros. Okay, now an equation like this hopefully shouldn't be too bad, however, just be careful about the negative sign there in front. So again, we're going to imagine this is 0 equals negative 2x to the fourth plus 8x squared. Okay, and really a couple different options open to you. One thing I kind of like to do in this case, at least one of the options, is I basically just move both terms to the other side. So by doing so, I get a positive 2x to the fourth minus 8x squared, and I can just solve that equation. For the sake of argument, let's pretend that we don't do that, and we just look at that and say, oh, let's factor. So looking at this, my GCF, and again, a good idea if you have a negative lead coefficient is to factor out that negative number as part of your GCF. So I'm going to factor out a negative 2x to the second. Okay, that leaves me with, again, watch your signs here. That's going to give me an x squared. Factoring a negative 2 out of that gives me a negative 4, and all the x squareds went out with it. So I've got that, and honestly at this point, hopefully you don't need me to actually show this next step of factoring to get your answers, but there's that factoring. So basically our zeros are the x values. Okay, from x squared gives me 0. Again, notice that's a multiplicity of 2, so I'm going to put a little m2 next to that guy just to remind myself what's going on. And then I've got a negative 2, and I've got a positive 2. Okay, remember how that multiplicity is going to play out visually on the graph, but we'll get there when we get there. So now plotting these guys, I've got 0, negative 2, and positive 2. So in the x direction here, I don't need too many tick marks to get the point across, so I'll just go 4 either way. And plot at 0, plot at positive 2, and plot at negative 2. Alrighty, moving on along. I'm going to plot points between the zeros. Notice the operative word being between. Okay, so right here I've only got 3 zeros, and between I've only got 2 different spots between. I don't need on the end because of the end behavior test, I know exactly what that's going to be. I know this guy's going down on either side, so kind of I can draw that if I wanted to right now, but I'm going to hold off on that. Okay, so plotting points between the zeros, we just want to pick x values that are as nice as possible and work them out. Now in this case I didn't leave myself very many options, so I'm going to plot x equals negative 1, so basically what I want to find out is what f of 1 is and f of negative 1. Okay, the good news is those calculations will be fairly similar, but here we go. So negative 2 times 1 to the fourth plus 8 times 1 to the second. Alright, so 1 to the fourth is of course 1, so negative 2 times 1 is still negative 2. 1 squared is 1, plus 8, so that gives me 6. Okay, if you remember what you remember about even and odd functions and kind of stuff, the following calculation should be no shock to you. But if I take negative 2 times negative 1 to the fourth plus 8 times negative 1 squared, alright, again, negative 1 to the fourth is still going to be a positive 1, and then negative 2 times that positive 1 is still a negative 2, and then same thing, negative 1 squared is positive 1 times 8 is 8, so I also get 6. Okay, if you remember even functions, and because those are both even exponents, okay, I kind of knew in advance that the f of x and f of negative x would come out to be the same value. But anyway, here we go. So I've got 1/6 and negative 1/6. So negative 1, and so I don't need too many tick marks here either. 1, 2, 3, 4, 5, 6. Of course, depending on the numbers you get, you might want to do tick marks in increments of 2 or 5 or 10, because sometimes these high-powered things can get very, very big very, very fast. So feel free to do that. Alright, so I got a couple points up there. Again, my end behavior test told me that this guy's going to fall to the left and fall to the right on both sides. And again, remember that multiplicity of 2 basically means that my graph is going to come down, hit that 0 at the x-axis, and then kind of bounce off of it. Okay, so ultimately what's going on here is I've got my graph falling all the way on the left, kind of comes up, it hits this point now, and I can't be really sure this is the exact maximum point here, but I'm just going to kind of approximate it. Okay, it's going to come down here, and again, because it's a double root, it's going to bounce off right there. Again, it goes to this point. This may or may not exactly be the highest point of my graph, but again, we'll just kind of do our best with it. And then, well, hopefully you can do a better job of hitting the 0 than I just did. And it goes to the graph. Okay, if you want for effect to put a few tick marks down there, that's great. But overall, there's a fairly accurate by hand graph of that function. Yeah, so there it is. Again, once you get into calculus, there's some little tricks you can do to find those points a little bit better, but again, we'll cross that bridge when we get to it. Alright, going on to another one of these guys, just to show an example of what happens when you have an odd exponent. Alright, and again, notice how we've got first power, second power, third power. So when I'm doing my lead coefficient test on this particular function, I'm looking actually at the last term. Of course, if this messes with you, just rewrite the function so that the lead coefficient is actually in front. Okay, just pay attention to the signs here. Granted, I use all positives, so there's not too much worry about that, but just be careful. Make sure you keep the signs on whatever terms you have. Alright, so if you're better off looking at that, great, more power to you. But again, the lead coefficient test, mostly what I'm looking for is to know basically what this guy's going to look like. And again, I've got an odd power, so I know I've got my monkey sort of effect going on. And again, it's positive, so I maintain the low left, high right sort of effect going on. And again, with a 3 power, I'm dealing with maybe 2 turning points at most. So again, maybe low left, I'm going to come up, go, something maybe kind of like that. Okay, so that's what I'm expecting when I'm done. If I get something markedly different from that, I should go, oh man, and go around and check my work. But here we go. Okay, I'm going to find and plot any zeros. Okay, I have my graph on the next slide, so I'll plot them once we get there, but here we go. Okay, so 0 equals, and again, depending on your comfort level, you might want to go with, the rewritten version of it over there, and I'll do that just so that people aren't freaking out on me when I do the factoring with the square in the back. But here we go. That. Okay, again, factoring out GCF if there is one. In this case, we have the x, so x squared plus 8x plus 12. Alright, and then, of course, this is something that factors pretty nicely, is x plus 2 and x plus 6. Okay, so right now I've got zeros at 0, coincidentally, -2, and -6. Now notice they're all multiplicity of 1. So every time these guys are going to hit the x-axis, it's going to pass right through. We're not going to go tangent like we did in the last example. Okay, but anyway, I've got 0, -2, and -6, and we'll use those here in just a second. Alright, we just found 0, -2, and -6 as zeros. So I'll just recopy those just so they're on the screen. Although if you've been taking notes, you got them on your paper. Alright, so anyway, don't have terribly big numbers here either, so again, this is kind of convenient in the x direction at least. So 1, 2, 3, 4, 5, 6, 7, just to give a little room. 1, 2, 3, 4, 5, although I don't really need that much. And then, oops, I don't want to do anything there yet. Okay, got a 0, got a -2, and then 3, 4, 5, 6. Okay, so kind of most of the fun part of this graph is happening on the left. Okay, again, plotting points between the zeros. Again, I don't care about the extreme left and extreme right because I already know what's going on there. So I'm just, again, picking numbers in here. So again, I'm going to be able to pick -1, and then I need to pick something over here. Admittedly, for accuracy purposes, it's probably a good idea to pick something kind of in the middle, but for the sake of argument, I'm not going to worry about it too much. So if you want to pick -3 here, that's great, or -5, or -5.73819, although I think that'd be silly. I'm going to go with -4. So we're going to go with f of -1 first. So, oops, well, I guess I'll start on this end of it. 8 times -1 squared plus -1 to the third. Okay, and notice how I'm kind of doing this by hand. Hint, you might have to do this without a calculator. -12, okay, plus 1 squared. -1 squared is 1, times 8 is a nice 8. And then -1 to the third is going to be a -1. So f of -1 actually works out to be -12 plus 8 is -4, minus 1 is -5. Okay, so I've got -1, then I've got 1, 2, 3, 4, 5 down. And again, not such a bad number, although admittedly I probably should have waited to find out what comes out of -4 before I did tick marks there, because I might find myself in trouble here in just a second. But anyway, like I said, I'll do -4 because that's right in the middle between these two zeros. So 12 times -4, ooh, that's going to be kind of big. 8 times -4 squared, also kind of big, plus -4 to the third. Ooh, scary. Alright, so anyway, I get a -48, 4 squared is 16, and everybody knows that 16 times 8 is about 128. And then I've got -4 to the third, which is a -64. Alright, now putting this mess together, 64, and I think that works out to be 16. I'm sure somebody's going to yell at me if I'm wrong, but there it is. Alright, so f of -4 is 16, so, well, I'm going to have to kind of fudge this a little bit here. Let's call it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Let's pretend those are evenly spaced like the bottom is. So at -4, 16 puts me about right there. Okay, and again, because what I did, and with the lead coefficient test and everything else, I can draw a nice smooth curve. Again, low left comes up here, and again, that may or may not be exactly the highest point, but we'll just pretend it is for now. And come back down there and hit it. And passing through each zero, because there are multiplicities of 1, gives me, our standard monkey graph, and looks pretty nice. And again, not a single bit of calculator work was necessary. Alrighty, moving on to word problems now. Hoo-ah! I know you're excited. So excited, in fact, that I doubt you'll be able to sleep tonight. But here we go. We got an open box. It can be made from a 24-inch square piece of material by folding and cutting the edges as shown in the diagram. Pardon me for putting the words backwards there. Alright, so anyway, I've got this 24-inch square, and again, notice by these x's up here, I'm cutting one x off of one side, and kind of two x's off in the other direction. Okay, so that's going to make a little more interesting sort of thing as we fold the box up as such. It's kind of a lot of the way that pizza boxes are folded. This coming from somebody who worked 16 years delivering pizza. But anyway, moving right along here. Okay, if I look at the horizontal dimension of this guy, notice I've taken two x's off of the one side and two x's off of the other. So basically, if I'm looking at just this piece along there, okay, that dimension right there is actually going to be the original 24 minus 4 x's. Okay, translating over here, this diagram, that's kind of like this diagonal measurement right here, 24 minus 4x. Okay, in a similar fashion, if I take a look at this dimension of the box, this vertical, okay, after we cut off this, or at least cut it so that we can fold things up, like it shows in the diagram, okay, I initially would have 24, but I've cut 1x on either side, so this is going to be 24 minus 2x. And again, that kind of corresponds to this piece over here, 24 minus 2x. Okay, and lastly, you see all these little corners of x's, those is what got folded together. Those are what got folded together. Oh my gosh, don't tell your English teacher. Okay, so anyway, I've got my x over there as my kind of third dimension of my box. So in terms of the box that we have, of course, in general, volume equals length times width times height. And in this case, alright, okay, I'm going to do this in kind of a messed up order just to make it easier to get to our answer. Alright, I'm going to do my height first, which is x. Okay, and then the length and the width are kind of irrelevant, and just because a little bit of foreshadowing and forethought looking at this answer versus what I have here, okay, I'm purposely going to write my 24 minus 2x first, and then my 24 minus 4x second. Okay, now, the reason I did that is to try to match the answer that the book is trying to get us to get to. Okay, so notice I've got this 8 in front, and I've got these guys that, okay, whatever. But if I look at my first parenthesis, I've got a common factor of 2. So basically, I'm going to take a 2 out of this guy and throw him in front. Likewise, this guy's got a common factor of 4, so I'm going to pull that out as well. Of course, the 2 and the 4 get together and make an 8. They join up with that x out there. And then what's left out of this first parenthesis is a 12 minus x. And what's left out of the second parenthesis by dividing by 4 is 6 minus x, which, oh my gosh, coincidentally, is exactly the target we're shooting for. Okay, now that we've determined our basic volume formula in the format of the book, which actually will make it a little bit nicer to do what we're about to do here in Part B, determine the domain, that's something we can do. Alright, so we've got v equals this. Okay, again, we got to think context of the real world here. Alright, so as soon as I try putting any sort of negative values, I'm going to run into trouble because this ends up being, the height of our box, the x. So basically for the domain, I have to be bigger than 0. So just do interval notation, just to mess with those of you who don't like it. I'm going to start out with 0 right here. Okay, and then as far as how big I can go, well, looking at these two different parentheses here, well, of course I can plug anything in correct, so I have to look over here. Okay, here I can go up to 12 before I run into trouble, but over here, if I look at this x, the second I get over 6, I'm in trouble, because then I start getting negatives. So basically, the largest I can have is 6. Okay, and I can't quite go to 6, because then effectively I have no box. So I gotta go short of 6, so 5.999 is good, but 6 isn't. Alright, so basically there's your domain. Okay, now that kind of a little hint if you looked at the graph that I already had here. Alright, here's sketching a graph. And realistically, again, if the domain is 0 to 6, I don't care about the rest of the graph. I mean, this is the only thing that makes sense to me as far as getting the box put together right. So sketching the graph and estimating the value of x where v is a max. Okay, and again, remember that my basic function is v equals, so the y is kind of my volume, and then this is my x-axis here, so my volume axis and x-axis. Alright, so again, to get the maximum volume, that's going to be about right there by look of things. And again, if I'm estimating that, I would say that it's, so my estimation looks to be 2.8, 2.9-ish. 2.8-ish. Okay. So again, can't really do too much better than that with just the picture itself, but again, if you did that on a calculator and calculated, the various, y min, y max kind of sort of stuff going on, alright, you should have been able to get that via the calculator here, should be able to find out that that x value is actually 2.535 and then some other icky decimals. Alright, so basically if this was a quiz, you would correctly round to the nearest tenth by saying 2.5, and then the volume that you would have got, in case you were asked, is 665.1075 ... So again, if this is a quiz question, you'd say 665.1. Alright, so anyway, sketching graph and estimate the value. There were no directions here, but based on what we said here, I'm going to go with x equals 2.5, just being exact as possible, because honestly, if you're going to graph that on a calculator, why not use the tools available to get the exact coordinates at that point. Alrighty, so now for approximating zeros. Alright, okay, this is intended to be a graphing calculator sort of thing, because otherwise if you're trying to draw it by hand and then make an approximation of it, it's pretty inaccurate, so I'm not going to make you go through that torture. If I'm going to have you do it by hand, I'm going to make sure the zeros work out super nice for you. Okay, but anyway, here we go. Okay, so I've got the graph of this particular function, and admittedly I picked a function that would be very easy to do by hand if you had to. And we get this nice barrel of monkey sort of graph to it, which is great. Okay, and if using a calculator, if we did this, well, hopefully no shock here, this guy would work out to be 0, so I got x equals 0. Okay, and over here, as we do my left bound, right bound guess sort of thing, okay, the value there we would get is 2.449 and some icky other decimals, so 2.449 whatever. Okay, that would not round to 2.5, that would be rounded to 2.4. And then this looks pretty symmetrical, and well, it is. So if we go and find this guy over here, it's negative 2.449, and again some other icky decimals, and what I'd look for an answer for there is negative 2.4. So there's that. Okay, what I want to briefly discuss right here though is, imagine if we had no graphing calculator to do this with. We'd have to set this guy equal to 0 and go with this, go through our factoring, taking out the x, leaving the x squared minus 6, and then, well, hopefully you don't yell at me too much for doing this, but I would get x equals 0, and then this would give me a plus or minus, and I know nobody would ever forget to do that. I'd end up with the square root of 6. Alright, so the difference between what the calculator spits out and what you can do by hand is the square root of 6 is exact. Okay, this is an irrational number and represents all those decimals all at once. The second you do this, you've rounded it. 2.4 is certainly not the square root of 6. It's close. Look at the decimals, and you're off by a little bit. But if I want an exact answer, this is what I'm looking for. If I want a rounded answer, I'm looking for these decimals over here. Basically, word of thumb, or rule of thumb, is on a quiz that I give, if I give in the directions that you should round something, okay, go ahead and give me those decimals. If my directions don't include any sort of directions about rounding, I'm going to be looking for this thing on the left here. So try to pay attention to that, and just keep in mind that your calculator cannot yet give exact values for irrational zeros. So even if you had your calculator in hand, and I was looking for an answer like that, and you didn't give it to me, well, then kind of bad news. So just make sure your calculator is a wonderful tool, and it can do some great things, but one thing it can't do is take this graph and pull root 6 off of it. The only way around that is what you would have to do is memorize the various decimals for all these square roots that I don't really advise you doing. So just beware of the limitations of the tool you're using when you use it. Alrighty then, so here's the assignment. Nothing too much to say about it. There's not too many problems listed, but it's one of those things where, as you saw in the video, that some of these take quite a while to do. So don't be fooled that it's super short, but there it is. Alright, and one final word is I did find myself in a situation this weekend where, you know, it's one of those things that you really need to do it if you have the chance to in your life. So I leave you with the following picture. See you in class.